morning to one and all. My name is B. Mohan Kumar. I am studying first B Farm in Raipur College. Today I am going to discuss about the topic expectorants. Before going to the topic expectorants, we have to know that where we are using these expectorants and why we are using these expectorants. We are using these expectorants to treat the cough. Why we are using to treat cough and where we are using in preparation of the cough mixture. Before going to the topic expectorants, we have to know that cough. What do you mean by cough? It is a protective reflex. It is protective reflex and it is going to protect you from the any foreign particles that enter into the respiratory tract. Expectorants are the drugs which are used to remove the sputum from the respiratory tract. These expectorants, based upon the mechanism of action, again classified into the two types. The mechanisms are, there are two mechanisms of these expectorants. First one is increasing the fluidity of expectorants, increasing the fluidity, and the second mechanism is increasing the volume of. Based upon this mechanism, the again expectorants are again classified into the two types. First one is the expectorants. Expectorants. These are the expectorants which are used to, which cause the sleep while taking this. These are the stomach irritant expectorants. These are stomach irritant expectorants. They cause sleep. They produce their action by gastric reflex. An example of this is antimony, potassium tartrate, and the ammonium chloride. And third one is potassium iodide. And next one is sodium citrate. Etc. Sedative expectorants, they cause the stomach irritant expectorants. While taking these sedative expectorants, they cause the stomach irritant. They cause us irritant to the stomach while we are taking these sedative expectorants. While taking these expectorants, they cause us sleepy and trauma in nature, and they produce their action by the gastric reflexes. While taking these sedative expectorants, how they act, how they produce their action. They produce their action by the gastric reflexes. And the example of these sedative expectorants are antimony, potassium tartrate, ammonium chloride, potassium iodide, and the sodium citrate. And the second one is stimulant expectorants. Stimulant expectorants. They cause the stimulation of, these stimulant expectorants stimulate the secretory cells in the respiratory tract. So the volume of fluids in the respiratory tract, in the esophagus and the lungs increase by these stimulant expectorants. When we take this stimulant expectorants, they cause the stimulation of the secretory cells. Normally they produce some range of the volume of the fluids. While taking these stimulant expectorants, they cause the more secretion of these secretory cells or any substances in the respiratory tract like a mucus. So they increase the volume of fluids. Increases the volume of fluids. Increases the volume of fluids, and then by what is the use of increasing of this body fluids? By increasing the more body fluids, if the sputum is attached to the any mucous membrane of esophagus like that, the sputum is get diluted. While more secretion of the body fluids, the sputum is diluted. So the mucus or any sputum that easily get away from the mouth by a coughing. The sputum is diluted, that causes the cough, which can easily get out of this sputum from the respiratory tract. And the example of this stimulant expectorants is the terpene hydrate A. Terpene hydrate. These are the expectorants and their classification. And briefly I discuss again expectorants are the drugs which are to remove the sputum from the respiratory tract by the two mechanisms, by increasing the fluidity or increasing the volume of the body fluids. Sedative expectorants. These are the stomach irritant expectorants. They cause sleep while taking these expectorants. They produce their action by the gastric reflexes. And the example of this is antimony potassium tartrate and ammonium chloride and potassium iodide and sodium citrate. And the stimulant expectorants. They cause the stimulate the secretory cells in the respiratory tract. They increase the volume of body fluids. The sputum is diluted and get easily away from the mouth. Example of this is terpene hydrate. Now we are going to discuss about the compounds of the expectorants like ammonium chloride and the potassium iodide. In our syllabus, there are star mark compound is ammonium chloride is important, and the second one is the potassium iodide. Ammonium chloride. The chemical formula of the ammonium chloride is NH4Cl and the molecular weight is 53.49 gram per mole, and the synonym is, and it is also called as ammoniac salt or muriate of ammonia. And the physical properties, its color is white in color, and odor is odorless, taste is tasteless, the state of this ammonium chloride is crystalline in nature. It is in the form of powders like a salts. And the solubility, it is soluble in water and glycerin. Its storage, it is stored in well closed container These are the physical properties: color, odor, taste, state, solubility and storage. And we are going to discuss about the chemical properties. When ammonium chloride is reacted with a strong base like NaOH, it gives a sodium chloride and the ammonium hydroxide. It is the one chemical property. When ammonium chloride is reacted with the sodium hydroxide, it gives the sodium chloride and the ammonium hydroxide. It is one chemical property. And next is preparation of the ammonium chloride. It is prepared by two methods or so many methods. We are going to discuss about two methods. And first method is neutralizing of ammonia. Neutralizing method. NH3 plus HCl, I mean hydrochloric acid, gives rise to ammonium chloride. It is a base and it is acid, gives rise to salt. We have a principle: acid plus base gives rise to salt plus water, and the water is evaporated and ammonium salt is collected. Ammonia plus hydrochloric acid gives rise to the ammonium chloride. And the second method is reacting the ammonium sulfate with the gives rise to ammonia plus hydrochloric acid plus sodium sulfate. Ammonium chloride, ammonia plus HCl plus sodium sulfate. And again this ammonia plus HCl neutralizes, ammonia plus HCl neutralizes gives to the ammonium chloride. These are the preparation two methods, first one and second one. Ammonium sulfate plus sodium chloride gives rise to ammonium plus hydrochloric acid plus and the sodium sulfate. This ammonia again, this one reacted with each other to form the ammonium chloride. And next we are going to discuss about the assay of ammonium chloride. It is mainly assayed by the two methods, acid-base titration method and Olhart's method. First one, acid-base titration method. In this method, first we have to take 0.1 gram of ammonium chloride sample and we are going to add a 50 ml of water and 5 ml of formaldehyde and again add in a 2 drops of phenolphthalein indicator and titrate against with the NaOH and appearance of the pale pink color is the end point. First we have to take in a conical flask. First we have to take 0.1 gram of sample RNA ammonium chloride. Sample or ammonium chloride. And then we have to add a 50 ml of water to dissolve of ammonium chloride. 50 ml of distilled water. And then add a 5 ml of formaldehyde. And add a 2 drops of indicator. Phenolphthalein indicator. And the indicator is phenolphthalein. Indicator is phenolphthalein. And the endpoint is pale pink color. And titrant is sodium hydroxide. First we have to take 0.1 gram of ammonium chloride and 50 ml of distilled water and 5 ml of formaldehyde and 2 drops of indicator. And it is stated against with the sodium hydroxide. And 2 drops of indicator is added and is titrated with phenolphthalein until the titrate appearance of pale pink color. This is the first method, acid-base titration method. And the second method is Olhart's method. First we have to take 0.2 grams of ammonium chloride plus 40 ml of water to dissolve plus 3 ml of dilute nitric acid HNO3 and 50 ml of 0.1 normal of silver nitrate and again 5 ml of nitrobenzene and 2 drops of indicator. In this titrant is ammonium thiocyanate and the indicator is ferric ammonium sulfate, ferric ammonium sulfate indicator, and the indicator and titrate. In this Olhart's method, first we have to take 0.2 grams of ammonium chloride sample and dissolve in a 40 ml of water and add 3 ml of nitric acid and 50 ml of 0.1 normal of silver nitrate and 5 ml of nitrobenzene and 2 drops of indicator of ferric ammonium sulfate, and it is titrated with the ammonium thiocyanate up to appearance of endpoint. Next, uses of the ammonium chloride. First, it is used as acidifying agent, and it is used as act as a mild expectorant, and diaphoretic, and it is a source of ammonia, and it is an a deamination. It is used helps in the deamination of amino acids, etc. It is mainly used as acidifying agent. It is acts as a mild expectorant, and it is a source of ammonia. It is source of ammonia, and it is a deamination of amino acids.